Okay, so we're going to talk about functions that have a higher degree. All right, when f is a polynomial and a is a real number, then the following statements are equivalent. X equals a is a zero of the function f. X equals a is a solution of this polynomial, f of x equals 0. X minus a is a factor of the polynomial, and a comma 0 is an x-intercept. So those are just some statements that are true, okay? So what we want to do is we want to find these zeros, and we do that by factoring. All right, so I look at that first, and I notice that I have an x to the third, an x to the second, and then an x in this one. So I need to take out my common factor of x. So if I divide an x out, that leaves me with x to the second minus x to the first minus 2. Now I have a quadratic that I can split into two binomials. So I'm going to go ahead and split this into 2. And I look at that sign at the back, and I see that I have a minus sign, so I know that I'm going to have a plus and a minus. And then in order to get the x squared in the front, I would have to have x and x. And I'm looking for two numbers that will multiply to make this 2 back here and subtract to make the 1 in the middle. All right, well, the only thing that multiplies to make 2 is 2 and 1, and that does subtract to make 1. So I just have to think about where to put the 2 and where to put the 1. I want this middle to be negative, so I need the 2 to be negative and the 1 to be positive. All right, that way when I do the middle, I've got negative 2x, positive 1x, which makes a negative 1x. So I'm going to take all three of these factors, the x, set that equal to 0, the x plus 1, set that equal to 0, and the x minus 2. And then I just solve for x. So I'm going to get x equals negative 1. And then I'm also going to get x is equal to 2. So I get x equals 0, x equals negative 1, and x equals 2. If you would prefer, you can always do the little bracket with 0, negative 1, and 2 to show that those are all your answers. In fact, I would probably prefer that. That way I don't have to search for all three of your boxes. So if you'll put them in brackets with your three numbers, I don't really care what order they go in. All right. Normally you do them from least to greatest, but I'm not that picky. I'm also going to point out that if your biggest degree is 3, then that means you're going to have 3 zeros. Now they may not all be real zeros. You may have some imaginary zeros, but you should have 3 zeros nonetheless. All right, so number 2, first thing I look for is a common factor. So I have an x. I'm going to take that x out, which leaves me with x to the second plus x minus 6. And then I'm going to do this whole process again. So I have a quadratic equation right here that I can factor into 2. So I look back here and I see that I have a minus sign, so I have 1 plus 1 minus. And then to get the x squared, I have x and x. And then I need two numbers that will multiply to make the 6 and subtract to make 1. Well, 6 and 1, that would subtract to make 5. 3 and 2 multiply to make 6, and they do subtract to make 1. Now I want that in the middle to be positive. So I know the 3 is going to go with the plus and the 2 will go with the minus. Now I have my three factors. I'll set those equal to 0. And that's going to give me 0, a negative 3, and a positive 2 for my set of numbers. All right, so number 3 is pretty much exactly the same thing. I notice that I have a common factor of x, so I'm going to take that out first. That leaves me with x to the second minus 12x x plus 36. Now I can factor this trinomial. I look at the back, I have a plus sign, so that means I'm going to have 2 of whatever is up here. So I have 2 minus signs. And then I have x and x. And I need 2 numbers that multiply to make 36 and add to make 12. So that would be 6 times 6 is 36, and 6 plus 6 is 12. So they both go here. Now these two are exactly the same. So I don't need to actually work both of them out. I can just set one of them equal to 0. But I do need to recognize that I'm going to end up with that answer 2 times. So when I write down my answers, I have 0, then I have 6, but that has to count for 2. So when I need to show that it counts for 2, I'm going to say that it has a multiplicity, I'm just going to abbreviate that, of 2. That just says, hey, I have 2 of these. And really what that means is that's going to turn on the x-axis at 6. So if you had 6 out here, I don't know how this graph looks, but it's going to turn right there, and that counts for 2. All right, and that makes up our 3 zeros, right? 1, 2, 3. That counts for 2. All right, we're finding all real zeros. All right, and we're not going to do this part. We're going to ignore that so you can work that out. We're just going to find all the real zeros. So I'm going to go ahead and I look at this and I notice that both of these will divide by 2. And I don't like for my biggest one, my biggest degree, to have a negative. So I'm going to take out a negative 2. And then also I have 4 x's here and I have 2 x's here. So I can take out the smallest number of those, which would be the x squared. So if I divide this, negative 2x to the 4th divided by negative 2x squared is a positive x to the 2nd. And 2x squared divided by negative 2x squared is negative 1. All right, so remember, if I were to multiply this back, I should get the same thing that I had. So negative 2x squared times x squared would be negative 2x to the 4th. And negative 2x squared times negative 1 would be positive 2x squared. So I look at this. I'm going to set that front term equal to 0. And then I notice that this is not a trinomial, but it is the difference of 2 perfect squares, which will split into 2 binomials. So remember, when you have the difference of 2 squares, that means you have to have a minus sign, and the front and back numbers have to be perfect squares. You're going to have a positive and a negative. And then you just square root the front term, which is x squared, so that would be x and x. And then you square root the back number. The square root of 1 is 1. And that goes at the back. Now you have factored that out. And really all that did was, if you think about it, remember the outsides and the insides make up your middle term. Well, you don't have a middle term, which means they cancel, right? This would be negative x, and this would be positive x, which would cancel. That's why you don't have a middle. All right, so I have 3 terms. I'm going to set them all equal to 0. Now, I did have the biggest power is a 4, which means I should have 4 zeros. Now, remember, that could be a mixture of real and imaginary, but I should have 4 no matter what. Well, I'm only showing 3 here, but one of these is going to count for more than 1, right? So here's the deal. I'm going to go ahead and solve for x here. So I divide by the negative 2. I have x squared equals 0. And then to solve for this, I will square root. And remember, when we square root, this counts for a positive and a negative. You can't have a positive and a negative 0, but that counts for 2 answers. So that's going to be 0 is going to have a multiplicity of 2 because technically we would have had 2 if it wasn't 0, right? If this was a 4, it would be positive 4, negative 4. That's 2 answers. So this is going to count for 2. This one, I just get negative 1. And then over here, I just get positive 1. So for my set, I've got 0, but remember 0 has a multiplicity of 2. Negative 1 and positive 1, and there's my 4 zeros. Okay, so for a polynomial function, a factor of x minus a to the k power, k is bigger than 1, yields a repeated 0, which we just talked about, right? A repeated 0 of x equals a of multiplicity k, okay? If k is odd, then the graph crosses the x-axis at x equals a. If k is even, then the graph touches the x-axis but does not cross at x equals a. Okay, it like touches and turns around. Okay, so for number 5, we don't have a way to factor when we have a power of 5. So we know that we should end up with 5 zeros total. So they could be all real, they could be imaginary, they could be a mixture of both. The problem is that we can't factor this as it is. So we kind of have to narrow it down. So that's where we're going to work on this right here. Okay. Okay. So I thought we were on one part of this, but we're actually on a different part. So we can't factor this. I just stated that. But if we were to go to the calculator, we could actually have it find the zeros for us. Now remember, we have 5 total, but they may not all be real zeros. So we're going to grab our calculator. And inside the y equals, we're going to put in the x to the 5th minus 3x to the 3rd minus x squared minus 4x minus 1. And then we're going to go ahead and graph it. So remember, real zeros cross the x-axis, or at least touch and turn, right? So we have 1 0 here, we have another 0 right here, and we have another 0 right here. That's only 3. And if we have 5 total, that means that 2 of them have to be imaginary zeros, right? They'll have an I in them. So I can actually have my calculator tell me what these numbers are. Okay, now you're going to be doing these by hand because I don't like the decimals, and that's what you're going to get here because none of them cross evenly. But you can still use your calculator to find those. So you would go to the calculate menu, which is second, trace, and you want to find the zeros, right, which are the same thing as your x-intercepts. Now remember, you have to do each one of these separate, okay? So if I want to find this 0, then I need to go to the left side of that 0. Okay, and you're going to press enter. And then you've got to go to the right side of the 0 and press enter. See how your little x-intercept is right there in between, and then it's asking for a guess. You say yes. So right there, negative 1 point, we'll just round that to 9. So negative 1.9 is one of your zeros, right? Negative 1.9. All right, then you're going to do the same thing, except you're going to do it to this one right here. So you go back to your calculate menu, the 0, and you want to be on the left side of this 0, so we'll press enter. Then get on the right side and press enter, and then press enter. All right, we jump right there, and we see that's negative 0.25. We'll round there. So negative 0.25. All right. And then you'll do it one more time for the third 0. So we'll go to our calculate menu, 0, get on the left. Oop, too far. Get on the right. It pops down, and right there, 2.1. So those would be your 3 zeros. But since we can't factor this, we have to come up with a different way to work these out so that we don't have to deal with, I don't want the decimals. So they may be square roots, okay, or some sort of fraction. So we're going to go ahead and review how to do that. Okay, so all right, so we're going to add a problem in here. We'll just add it to this page here. We're not going to do this one. We'll just call this 5a. All right, I'm going to give you an equation, and we're going to go through this process, which we did in Algebra 2. So x to the 5th plus x to the 4th minus 2x to the 3rd minus 4x squared plus x plus 1. All right. You're going to have to, since you can't factor this, and we know that we have 5 zeros in total, okay? You could graph this. This one would actually come out nicely, but they don't all come out nicely, so this is why we're going to go through the process. So you're going to take all the factors of this back number, which in this case is just 1. So we have plus or minus 1. And you're going to divide that by all of the factors of this front number, which is 1. So this one's actually easy. 1 divided by 1 is just 1. So you have two options here, okay? This graph only has 2 possible real zeros here, rational zeros, okay? I'm going to divide synthetically to see which one of these works, and maybe they both work, okay? I don't know yet, okay? Now I could graph this and see if it crosses at positive 1 or negative 1, and then I would know that one of those works. But we're going to start off with positive 1. So remember, when you synthetically divide, this is kind of a review of that. You got to make sure all of these are in order. So we have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, no x. And you have to make sure that you're not missing anything from the front. So if I started with x to the 5th, I have to have the rest of them after that. And then you're going to put all of the numbers that are in front in this box. So you have 1, and then in front of your x to the 4th, a 1, negative 2, negative 4, 1, and 1. So if you're missing one of these, you would have to put a 0 in its spot. Like if I didn't have an x to the 3rd, I would have to put a 0 right here. So the first thing you do, remember, is you take this first number inside the box and you drop that down. And then you multiply 1 times the one on the outside, which gives you 1. And then you add down, so that gives you 2. Then you multiply times the one on the outside. 1 times 2 is 2. And then you add, that makes 0. Then you multiply times the one on the outside, that gives you 0. Add together, that's negative 4. Negative 4 times 1 is negative 4. 1 and negative, oh, I just figured out a mistake. I wrote this down wrong. This is a negative 2 right here. Which is going to change this one right here. My fault. I'm just struggling today. Okay, so this is a negative 2. So when we add the 0, that's negative 2. All right, so negative 2 times 1 is negative 2. Plus 1 is negative 1 times 1 is negative 1 plus 1 is 0. Now, when you get this box right here represents your remainder. So we don't have a remainder, which means this divided evenly, right? And if you'll remember from Algebra 2, once you divide through one time, then this becomes x to the fourth, x to the third, x to the second, x, and no x. So you still have x to the fourth, which you could factor by grouping, but why do that when you could divide again, right? So I could divide by 1 or negative 1. Now, it might have been helpful for us to graph it and look at it, and maybe we should just go ahead and do that. That way we can see if we should divide by 1 again or negative 1. All right, so I look and I say, okay, I'm going to put in the x to the fifth plus x to the fourth minus 2x cubed minus 2x squared plus x plus 1. All right, so if you look right here, it crosses at negative 1, and it turns on positive 1. So this one actually counts for 2. This one counts 1 time, right? So I could actually divide by this twice and the negative 1 once. All right, so I'm going to go ahead and divide by 1 again. So what you're going to do is just drop down the 1, the 2, the 0, negative 2, and negative 1 into the next box. And we're going to do that whole process again. So drop this first one down and multiply by 1. That gives me 1. 2 plus 1 is 3. 3 times 1 is 3. Add those two together, that makes 3. Times 1 is 3, plus a negative 2 gives me 1. Times 1 is 1. Add those together, I get a remainder of 0. So if we started with x to the fifth, this first term would be x to the fourth, and then if we divide again, this would be x to the third. So here we are again. We've got 4 terms, okay? And I already know that I could divide again by negative 1 because that's one of my zeros. So I'm going to divide again, and I'm just going to drop these down. 1, 3, 3, and 1. Same process. So I drop the 1. 1 times negative 1 is negative 1. Plus the 3 gives me 2. Times the negative 1 is negative 2. Plus 3 gives me 1. Times negative 1 is negative 1, which gives me a remainder of 0. So right now I have 3 zeros, right? This is what I have left over. Now if I started with x to the fifth, this is x to the fourth, this is x to the third, which means if I divided again, this would be x to the second. So 1x to the second plus 2x plus 1. Okay? Now, all right, so I'm going to go ahead and factor that. Finally got to something that I can factor. So I look at that back sign. I have a plus sign, which means I'm going to look up front, and I have 2 of what's up there. So I have a positive and a positive. Then to get my x squared, I have x times x. And I'm looking for what multiplies to make 1 and adds to make 2. Well, the only thing that multiplies to make 1 is 1 and 1, and that adds to make 2, so you have 1 and 1. So I set both of those equal to 0, which it's the same one, so I don't need to do both of them. So that gives me x equals negative 1. So if I look at this, I have 2 of the ones, and then I have 1, 2, 3 of the negative ones. That makes up my 5 zeros. So when I list the 1, I would say multiplicity of 2. And then I have 3 of the negative ones. So negative 1 multiplicity of 3, which gives me 5 of them, right?